This video is on conditional probability. This first example, we are not using conditional probability. We're going to be using basic probability and understanding the symbols and what this is asking us. So the table shows students by gender at 2-year and 4-year colleges and graduate schools in 2005. You pick a student at random. We want to know the probability of female, probability of male, probability of female and in grad school, and probability of male or in a 4-year college. So what we need to know first is we need to know the totals. So there are 3 different rows but 2 different columns. So we need to know the whole total of males, all the totals of females, the totals of 2-year colleges, 4-year colleges, and graduate schools. Then we need to know the total of all the people in this study. So in order to do this, you just add up the values. So the total number of 2-year colleges would be 4,328. The total of 4-year colleges is 9,841. The total of graduate schools are 3,303. The total number of males are 7,539. And the total number of females is 9,933. Now this is in thousands, so this is 9,933 thousand of females. So the whole total of the entire group would be 17,472. You could find that by either adding up these 3 numbers, or you can add these 2 numbers together to get your total. The reason we need to know our total is because the probability. We want to know the probability, so we have to have our total of whichever it is we're looking for. Now we pick a student at random. We want the probability of just a female. So female is how many total females do we have? We have that 9,933 out of all of the students in total. That's 17,000. So our fraction would be 9,933 out of the 17,472, because this is just basic probability. The probability of this happening, of a female being chosen, is approximately 0.569. Now the probability of a male being chosen, if you think about it, you can only choose male or female, so these 2 probabilities should add up to a 1. So let's make sure that does. So the probability of male, we want the males divided by the total number of students. So we have 7,539 males out of the 17,472 students. So we plug that into our calculator, we get 3 significant figures of roughly 0.431. If you added those 2 numbers up, that gives you a value of 1, which means that you have a 100% chance of picking either a male or a female. So again, basic probability, we want the probability of female and in grad school. And is an overlap problem. We want the overlap. So again, of all of the students, we have 17,472 students. We want female and in grad school. So we have to find the overlap of the female and the graduate school. That's 1,954 females who are in graduate school. So again, overlap. And is an overlap. So we find the overlap of those 2 columns and the column in the row, and it's still out of all of the students. So the probability that a female who's in grad school has been selected is approximately 0.112. When it says the probability of male or in a 4-year college, since we're only picking 1 student, again, we add, but we have to subtract the overlap. Or is when we add, but we have to subtract the overlap. So we want the probability of male. So the probability of male was at 7,539 over 17,472. Then we want the probability, I put that in the wrong spot. 7,539 over 17,472. Plus, we want the probability of 4-year college. So the 4-year college would be 9,841. 9,841 over that 17,472. But then we have to subtract the overlap. So where do those two, male and in a four-year college, overlap? So we want to subtract, still out of the 17,472, we want the male and four-year college. This is where they overlap, the 4,324. So we subtract the 4,324. When we add these up and subtract, we'll end up getting 13,056 over the 17,472 students. So the probability that we select a male student or a student who's in a four-year college, then we will have the chance of it being roughly 0.747. There are 13,056 students that we would choose from. Of the thousands. Don't forget, this is 13,056,000 students that we could choose from. Remember, because we're doing an OR problem, we actually are increasing our chance of it happening. So you can actually, this part right here, I put this in the wrong spot, so just cross out or wipe that out.